Hello, friends. In this video, we're going to understand what parsing actually is and why almost every serious software system depends on it. Whenever you write code, open a web page, send JSON to an API, or even type a search query into Google, somewhere underneath, a parser is trying to understand structured meaning from raw text. That is the key idea here. Parsing is the process of taking plain input and turning it into a structure the computer can reason about. Humans naturally do this all the time. When you read the sentence 2 plus 3 times 5, your brain automatically understands the order of operations. A computer does not. It only sees characters. So parsing is basically the bridge between raw text and meaningful structure. And here's the interesting part. Compilers, browsers, SQL engines, configuration files, markdown editors, and even AI systems all rely on parsing internally. Next, let's see what actually happens inside a parser when code enters the system. Now, before parsing fully begins, most systems first break the text into smaller pieces, called tokens. This stage is usually called lexical analysis, or tokenization. For example, imagine the line, let total equals price plus tax. To us, that already looks meaningful, but internally, the system separates it into categories. Let becomes a keyword, total becomes an identifier, the equal sign becomes an assignment operator, and the plus sign becomes an arithmetic operator. Think of it like how Chrome separates a URL into protocol, domain name, and path before loading the page. The parser does not want random characters. It wants organized building blocks. This is why compilers are often split into two stages. First, the lexer groups characters into tokens. Then the parser studies the relationships between those tokens. And this separation is extremely important because structured tokens are much easier to reason about than raw text streams. Next, let's see how the parser turns those tokens into an actual tree the computer can execute. This is where parsing becomes really interesting. The parser takes tokens and builds something called a parse tree, or syntax tree. This tree represents the structure of the expression, instead of just the text itself. Take the expression 2 plus 3 times 5. If a computer reads left to right without structure, it might accidentally calculate 2 plus 3 first. But mathematically, multiplication has higher priority. So the parser builds a tree where 3 times 5 becomes a deeper branch before the addition happens. This tree is incredibly important because almost every later stage depends on it. Compilers optimize code using these trees, browsers build HTML DOM trees using the same idea, SQL engines parse queries into execution plans. Even spreadsheet formulas internally become syntax trees. Underneath, parsing is really about discovering relationships and hierarchy. And honestly, this is one of the reasons computer science feels so mathematical. A parser is basically converting language into graph structures the machine can traverse efficiently. Next, let's look at where parsing shows up in real software you already use every day. Once you notice parsing, you start seeing it everywhere in computing. Web browsers parse HTML and CSS before rendering a page. Without parsing, the browser would just see a giant text file. APIs parse JSON responses into objects applications can manipulate directly. Databases parse SQL queries before deciding how to retrieve data efficiently. Programming languages parse source code before generating machine instructions. Even command line tools do this. When you run a command with flags and arguments, the shell parses your input first. And AI systems work similarly too. Large language models internally process tokens and relationships between them. Different architecture, same underlying idea of extracting structure from sequences. So parsing is not just a compiler topic. It is one of the foundational ideas behind how computers understand information at all. Now, let's wrap this up by connecting parsing back to the bigger picture in software engineering. So, in the end, parsing is really about understanding structure. Computers are incredibly fast, but they are completely literal. They cannot infer meaning from raw text the way humans do naturally. A parser gives structure to information, so the rest of the system can reason about it safely and efficiently. And once you understand this idea, a lot of software architecture suddenly makes more sense. Compilers, browsers, databases, interpreters, configuration systems, and even AI pipelines all depend on transforming unstructured input into organized representations. That is why parsing sits at the heart of computer science. Pretty simple idea on the surface, but underneath, it powers almost everything modern software does. All right, friends, that's the core idea behind parsing. In the next video, we can go one level deeper and explore how recursive descent parsers actually work internally.